Ladies and gentlemen, now it's time for the awards ceremony. Mr. Kani Korkmaz, a renowned Turkish mechanical systems designer, was recently nominated for the Rehva Designer Award for his invaluable contributions in HVAC plus R field. Rehva gladly accepted this nomination. And now I would like to invite Mr. Korkmaz and Professor Dr. Stefano Corgnati, President of Rehva, to the stage. Dr. Corgnati will deliver Mr. Korkmaz's award.
So, as Riva, we really would like to emphasize this moment. We are really proud about that. The award will be also delivered during an official ceremony, but it is always a great pleasure for us to be here as Riva, and to give in particular the emphasis about the high level of the technology, and we will have then time during our opening ceremony, during the cocktail this evening, to give you the plaque that we have, of course, with us, and in particular Manuel Gaverno da Silva, that chair the committee. So thanks a lot, and it is really a great pleasure for us to have you in our family. As according to our tradition, I give you the pin of Riva as a symbol of this participation to our European and international family of the Professional Award.
Distinguished guests, 2017 was the year in which the 25th inauguration of TTMD was celebrated. Since 1992, TTMD has been working with passion to produce and disseminate knowledge among its members. For this progress, TTMD was entitled to receive the Rehva Award. Dr. Kılkış, would you please come to the stage to receive the Rehva Award on behalf of TTMD?
I will just go and take the award. So again, for me, it's a great pleasure during my mandate to have this chance to be here for your anniversary, for the valuable activity you did here, but all over Europe. I have to, frankly speaking, the contribution of TTMD during these years has been great and increasing. Now you are one of the leader associations that we have in our Riva family. We are 28, and what is really important for us is that you, as a leader association, can help the growing of the young and small association to provide and homogeneous growing about our sector. So it's, for me, it's really a particular moment because, as some of you knows very well, I had lots of activity here in Turkey together with the Istanbul Technical University, with all of you. We published lots of papers together. So I really would like to thank you a lot, because your activity is fundamental now and will be more fundamental in the very next future. So thanks a lot, and thanks for being part of our family.
Thank you.
And I put you have three, but now we have also the one of Riva.
I receive with great honor this pin as a unique token of our collaboration, Europe-wide, worldwide, without any difference in science and technology for future challenges. Thank you.
Hello, this is Cem Çelik from Marmara University. So, indoor air quality is one of the most important issues, and it's a really important topic in getting more and more attention. So, in academic research papers also you can see this, the indoor air quality issue. The indoor air quality also directly related to the energy consumption and also the carbon emissions. So, as my colleague mentioned, the household energy consumption really consists most of the energy used in countries in Europe or also in developing countries, according to the statistics. So, this indoor air quality plays really an important role. So let me mention a little bit the components or the constituents of this indoor air quality topic. So most of mechanical engineers are related to the thermal comfort only, the temperature, the humidity, the air velocity. But besides, we also have to deal with the indoor air quality. So the parameters or the pollutants comes from the particulate matter or in chemical composition, and sometimes the biological ones. We need to deal with those to purify the air. Also, in environmental quality, we need to consider the acoustics. In this one, noise cancelling, the vibrations and reverberations have to be dealt with. Likewise, the lighting, especially the natural lighting, illumination, the adequate illumination is a necessary thing, and reflection. So, as a whole, we need to deal with these indoor environmental quality issue. So, the stuff that I'm going to talk about is mostly taken from European Union standards, and in all these slides you're going to see the categories 1, 2, and 3. So the first one is, over the top category, which is recommended. The second is the one in the middle, which is acceptable but not the best. The third is the one which is needed, necessary to improve. So, the human perception also plays an important role in the indoor air quality. It's the there are some questionnaires, surveys, and we need to understand the people's behavior or how do they feel about our temperature or humidity settings. So we need to measure the predicted percentage of dissatisfied occupants or dissatisfied people visiting the place, or the dissatisfaction about the drought, the excess of air velocity. So we need to classify, and according to this classification, we need to make some adjustments in our air heating, ventilating, and air conditioning system. So the indoor air temperature has also effects in people, but in majorly we have to adjust it, and the heating capacity, cooling capacity has to be calculated, loads has to be predicted, and the thermal zoning and ventilating parts has to be done properly, has to be dealt with proper attention. So the design and the control and management of the system plays an important role in indoor environmental quality. So for the same stuff regarding the categories, we have to set some temperature values in the comfort zone. So we need to make it better, make it up to category 1. And likewise, heating and cooling temperature intervals has to be carefully selected and also watched, and this represents the heating and cooling parts of the comfort zone. I mean, the temperature range in the heating part, and with the horizontal part is the heating zone, and the aligned part after the 15 degrees outdoor temperature is the cooling zone. So we need to be in this safe zone to feel comfortable. So these there are some parameters for this thermal discomfort. One of them is the floor temperature, which human must feel the temperature, shouldn't feel the temperature difference. The other one is vertical temperature from neck to ankle levels. It shouldn't, I mean, there shouldn't be a considerable difference, and also the air velocity and drought has to be minimal, or also in these categoric intervals. So indoor air quality is another important part, or in this indoor environmental quality issue, and most of us in Turkey and in Europe, in developing countries, most of the people live in cities and towns, so urbanization rate is quite high. And I mean, we all suffer from the air pollution in the cities, and it's probably get worse. And in many scientific research articles, it's indicated that the outside air is bad, okay, but
I first introduce myself shortly. I'm working for about HVAC design, energy efficiency about buildings, and energy modeling, and some kind of LEED certification, etc. Mainly energy efficiency for the buildings. My presentation is about improving of existing conditions of school, elementary schools. Why we have done this work? This is a project which includes Minister of Education and Environment, Minister of Environment. According to data from Ministry of Public Education, there are approximately 10,000 elementary guidance and high schools in Turkey. And there are approximately in these schools 250 classrooms and 3 million approximately these values are 500 students in these schools. On the other hand, major part of these existing schools don't meet standards and regulations because they are built especially before the 10,000 in Turkey, which main of the regulation published. Therefore, these schools need significant renovations. In this presentation, a study for improving indoor comfort conditions, temperature, ventilation, lighting, especially, and energy efficiency is summarized. This study was carried out Erdoğan Şahinoğlu and Elementary School. This school is located in Ankara. This is an example project, data from these or learning from this study, they can extend it other climate conditions of Turkey. These schools don't meet firefighting regulation, aircraft regulation, electrical system regulations, accessibility of disabled people regulation, but these are mandatory conditions for these ATIs, but these are constructed before 10,000 and they don't meet these regulations. But these mandatory requirements are not out of this presentation. This presentation includes indoor comfort conditions, improving comfort conditions, and energy efficiency. Also, parameters affecting the lighting efficiency, ventilation, and energy efficiency improvement are calculated. Example school is this in Ankara, elementary school. This school constructed 1995. There were no following regulation, as I mentioned before: earthquake, heat insulation regulation, energy efficiency regulation, firefighting regulation, electrical regulations. In the school has 31 classrooms and approximately 4,000 square meters. These are general values of these schools, approximately the same, because these are constructed as a same plan for different regions of Turkey. This is a typical sample floor plan. School has approximately, mainly 4 floors, each school. These are our boundary conditions for ventilation, energy efficiency, lighting, and U values. And school is, which times school is operated, etc. Holiday times, etc. for energy calculations. This school is located in the 3rd climate zone of Turkey, and also we investigated energy consumption, this kind of school when it is located, for example, other climatic conditions of Turkey. This data will be given end of this presentation. Firstly, we have done ventilation simulation because ventilation is necessary or mandatory for indoor air quality. Okay. We investigated natural ventilation, fan-assisted natural ventilation, heat recovery ventilation. When no ventilation, indoor CO2 concentration is above 3000 level. And we selected for ventilation 25 cubic meter per person for analysis. And firstly, natural ventilation is investigated, opening the window. And we found natural ventilation by window opening was checked and not found to be sufficient in volume and temperature, comfort, etc. Another alternative, fan-assisted natural ventilation, it can meet volume of volumetric of ventilation. It can meet what temperature, overheating or cold temperature in winter. This is not comfortable alternative. Also, overheating problem can be met in this system. Best alternative is mechanical ventilation with heat recovery. We have found centralized ventilation cannot be applied because existing buildings ceiling height is not suitable. These are for one for each classrooms. This can be applied ceiling of the classrooms is each classrooms. We analyze what happened, velocity distribution, etc. It will be here located, but there is a restriction. So we have to locate the side of the classroom. If we introduce this device into school, CO2 concentration can be below 1000 ppm. Okay, this is sufficient. Energy consumption is a little bit high other alternative fan-assisted alternative because there is a two fan in the system. Pros and cons, temperature, filtering, dust and pollen, etc. And temperature comfort, ventilation comfort is mechanical ventilation with heat recovery is best alternative. But some kind of climatic region also can be applied natural ventilation, maybe something like this. Energy efficiency simulation. This simulation ADSL TAS and career HEP program simulation programs was used. Some options we have accepted. Options 0 to option 6, existing conditions, and some other conditions, wall insulation, mechanical ventilation, etc. And lightning. This is Ashra chart, thermal comfort chart, which we have taken into account. This is facade insulation, approximately 10 centimeters for Ankara climatic condition is sufficient, found sufficient. If we increase this thickness, energy saving is very less. So, if we insulate facade of the building in summer times, maybe overheating problems, of course, because in night times building cannot be cooled down. Also here also overheating problem. And here payback periods for installation. Existing heating system should be replaced with condensing boilers and thermostatic valves for schools, resident schools. Non-condensing boiler, maximum efficiency approximately 80%. If we use condensing boiler, we can reach very high efficiency because if we insulate buildings, and we can use this type of boilers. Lighting system, LED system is found best alternative lifespan and lighting quality. Here, existing buildings, classroom, we can show. This is T5 fluorescent lamps, existing conditions. And shading and LED option, there may be some overheating also in for example, times. Pros and cons for lighting, LED and T5, and LED found is best suitable for these schools, comparing existing conditions. And we select option 2 as a base. And all of these improvements, overheating may also occur if we not use cooling system. If temperature 27, this is a limit, 500 Kelvin. Option for option 2. This is existing buildings, because in night time it cools down because there is no insulation. This is last slide of my presentation. Ankara energy consumption, yearly energy consumption, Bursa, Antalya, Erzurum, Samsun, etc. Current existing conditions, and not package 2. And if we improve the energy efficiency, that we can values for after improvement. But Antalya is needed cooling, some cooling system in April, and my times. Thank you very much.
Good morning, ladies and gentlemen. I'm Akhil Singhal from TERI, the Energy and Resources Institute, New Delhi, based out of India. So I would like to thank Professor Kilkish for inviting me here from all the way from India to here to present at the policy level interventions that can be done for Turkey and India and the further collaborations that can be explored. And for this panel, so I was asked to present on energy efficiency in the building sector and what beyond. So if we see, so I would take a moment and then briefly describe what are the outlines for my presentation. So my presentations would essentially cover, so basically I would be going around, so what is the mission that we are targeting, so what is the expertise available in India, energy efficiency in the building sector, Indian building scenario, and what next on energy efficiency in building, enforcement codes and guidelines, and then it would be carried with the conclusion itself. So we are basically a company established in 1974. So we were having the founder members as Tata Group. Mr. J.R.D. Tata was one of the key members to the founding associations. It was initially focused on documentation and information dissemination. The research perspective started somewhere in year 1982. TERI being one of the biggest organizations in India, so we have 6 regional centers and 6 global centers. So we have offices in Bangalore, Goa, Guwahati, Mumbai, Uttarakhand, and headquarters in Delhi itself. We have 6 international centers, one in Washington, Europe, Japan, Malaysia, UAE. So our mission is creating innovative solutions and providing sustainable future. So we have been in the research field for past 40 years and is now poised towards the policy side interventions and helping the government of India to create action plans and industry level actions into the policy briefs. So we have somewhere around 13 divisions in TERI itself. So it's a vast area of expertise that we are targeting. So if I wish to read through all the divisions, but it would take a lot of time. So holistically, we cover almost all aspects of sustainability in India and all across the world. So TERI has provided policy level outcomes for developing nations as well as the Asian development side. So sustainable habitat division, so where I basically work. So we have 3 sectors that are targeted within my group. Within my expertise, so Sustainable Buildings Program, Transport and Urban Governance, GRIHA. So GRIHA is the basically green rating for integrated habitat assessment. So it is the national rating system of India and a national green rating system for India. So any building, any government building that is being built in India, so it has to be a GRIHA certified building. So Sustainable Buildings Group, so we are targeting energy efficiency in the building sector. So we take care of energy audits, green building consultancy, integration of renewable energy with the buildings, research on sustainable building material, aligning it with the National Mission for Housing for All, which was launched by Mr. Narendra Modi, the Prime Minister of India. Occupant comfort studies and research on policy for energy efficiency in the building sector. So occupant comfort studies, we basically target the comfort level of the occupants. We are into the development of the guidelines for Indian context. And possibly by the end of this year, we'll be having guidelines for visual comfort and thermal comfort in Indian context developed for India and would come as a policy outcome and would be accepted wide across the Indian nation. So I would start with the basic and stick to the basic only. So what is a building? The scientific definition for a building. So permanent or temporary structure enclosed within exterior walls and the roof, including all attached apparatus, equipment and fixtures that cannot be removed without cutting into ceiling, floor or walls. So this is basically a very scientific definition. What is the basic definition? So building is essentially that separates the end user from the natural environment and creates an internal virtual environment. So this is what a basic purpose of a building is. So building acts as a third or a tertiary protective layer to the human. So first is the skin, second is the clothes, and third is the building. So if you're not having a building in place, so you will have to have the harsh environment and you will get the harsh beating from the environment itself. Indian building scenario, if I talk of. So initially, the architecture that was used in India was traditional vernacular buildings were used. Climate responsive architecture, passive heating and cooling was integrated into the building, and use of natural resources was the main criteria. If you can see here, so this is one of the best possible examples. So this is Hawa Mahal from Jaipur. So this was built basically because of two reasons. One was to allow the women from the royal family to see through any festivals, because at that certain time women were not allowed to look into the, to directly go into the streets and look at the festivals happening across the state. And second reason was to provide the cooling. So it has somewhere around 953 windows, jharokas as we say them. So if you can see this sort of structure that is there. So this is one of the passive architecture example. And then this was basically, this reduces the temperature of a building or the breeze that is flowing through the building somewhere around 15 degrees. And then either if the temperature outside is 40 degrees Celsius, you will have a temperature maintained somewhere around 24 degrees Celsius inside the palace itself. So this is one of the key applications that India was having initially. Nowadays, the modern buildings have taken over, which are energy intensive, emulates Western and modern architecture. However, this is the need of the hour, and then we cannot even skip it. So because of the scarcity of land, we have to move vertically upward. And then the energy intensity of these buildings are going haywirely increasing. So there is a need to provide energy efficient buildings and reduce the and the carbon footprint for that matter for these buildings is quite high. So if I talk of the carbon footprint, carbon emissions from a building, so 40% of the global energy consumption is building related. So 40% of the global energy that is consumed all across the world is coming from the building sector. 50% of the global greenhouse gas emissions are due to the buildings. So this is something I have already seen in the morning presentation, and data is quite verified, as the source is International Energy Agency, which has, from which the data has been taken. So 50% global greenhouse gas emissions are due to the building sector. So hence we need to reduce and work upon it to reduce the carbon emissions of the building and globally reduce the global temperature as it was signed in the Paris Agreement. In the 80% of the global GHG emissions are attributed to cities. So cities in India, so we are a country having 29 states and 6 union territories. So if I talk of the 80% of the global emissions are calculated to the city at a global level, and if it's then take up India, so it would be a very scary situation if I talk of the carbon emissions through the buildings in India, because first they are old, second they are not energy efficient, and third they are performing poorly. So this is the need of the hour. We need to improve on the energy efficiency in the buildings. So need for making the buildings energy efficient, reduction in reducing the energy consumption, so which would essentially lead to mitigating the GHG emissions and the overall impact on the environment, hence reducing carbon footprint of the built environment. As I already mentioned that in Indian condition, it is mandatory to reduce the building loads, to reduce the carbon footprint for the building, and hence this is the need of the hour. So what energy efficiency is? So energy efficiency, by what I understand, is something reducing the energy demand of a building by not compromising on the functionality of a building or the occupant comfort. So this is something that everyone needs to understand. Energy efficiency is not just you reduce your building load. It is about providing the highest level of comfort to the occupant and reducing the energy load to the maximum. So this is something the energy efficiency should look at. Otherwise, if I am working at an environment of having somewhere around 300 to 500 lux, and if I'm made to work in an environment where I have somewhere around 10 lux only, which is also generated from the computer screen, my productivity would go down the line. So hence it is required to make the occupant comfort as the maximum priority and reduce the building loads in terms of energy. So what is an efficient building? So an efficient building is basically a building which conserves natural resources, uses less water, generates less waste, optimize energy efficiency, provides healthier space to the occupants. So this is what energy efficient building is. So hence to reach to this level of energy efficient building, a person needs to have an integrated approach towards construction of building. So how would you increase the energy efficiency in buildings? Because since on the first day it was priorly mentioned that building is already achieved 90% of the efficiency. And then there's a very little gap that can be covered. So if we are targeting a 10% gap, so how much energy efficient can a building more be made? So there are only 3 parameters on which efficiency of a building depends: sustainable design practices, energy efficient equipments, and sources of energy. So sustainable design practices is basically something that can only be taken up while the building is into the construction phase. Once it has already been constructed, it becomes an existing building, and hence it cannot have the sustainable design practice in progress to it. Otherwise, you have to demolish it, create it again. So which incurs a lot of cost and is not environment friendly. Second parameter becomes energy efficient equipment. So energy efficient equipment can be done for both the cases, existing building and a new building. For a new building, it is very okay. It can be done, it can be implemented. So new building, it is fine. But for the existing building, when you have to retrofit everything, so consider a building having 20 story of floors, a hotel space if I consider of. So replacing a chiller for a hotel space would require the investment for a chiller, which would be somewhere around, if the capacity is somewhere around 300 TR, so it would be around 1 to 1.5 crore. So if I convert it to USD, it would be somewhere around 50,000, 1 lakh USD somewhere around. So that is a huge investment if I could talk for Indian market. So the people would not to invest first thing. Second thing, they would have to make the systems along with the chiller compliant with the chiller itself, because the chiller which was priorly installed to the new chiller, it might be of a lower TR or a lower system. So hence it might happen that the system is incompetent with the new chiller that is being placed. So it also, the possibility of this also is poses as a challenge. I wouldn't say that this is eliminated. This poses as a challenge. This is not eliminated. Sources of energy. So possibility of integrating the current conventional source of energy with the renewable energy. So this is one thing that can be explored upon, because India has a very high solar energy potential in comparison to other countries in the world. Having a good tropical range, so India receives sunlight almost almost all throughout the years, even in the remote areas. And then the potential of Indian solar market is somewhere around 500 gigawatts, which is estimated to be increasing as we pass by through the years. So sources of energy, but it would again require an investment. So the main point, if I come to, who would invest in those highly investment intensive processes? How it will happen? Technological advancement, I have already talked of. So technologically, we are very advanced. From past 3 days, we have been listening to all the technological interventions that has been made. Although no one has talked of the investment that is required for a technological intervention. Even if we talk of a ventilated blind, we talk of renewable energy, we talk of solar PV, we talk of integrating wind energy with the renewable sources of energy. So this would all incur some cost, and that some cost for Indian market is posing a challenge, because the builders are not ready to invest. Anyhow, why would anyone invest if in case I am asked to invest in India? India is a price-driven market, and it is a well-known situation all across the world that one thing that is not returning on the investment in India, so it won't sell. So this is one key challenge and key speciality about Indians that I would say, that we won't invest on anything that is not giving us a return on investment. Sustainable and best design practices, which is already achieved again. So we already have some very good buildings, great buildings in fact. If I talk of, we have high-rise buildings in Delhi, NCR region, in Mumbai, in Bangalore. But again, coming to the point, they have a higher energy-intensive processes. They are energy guzzlers basically. So they are guzzling energy. So they use a lot of energy in terms. And then why would they again invest in something that was priorly required by them? So coming to it, what next? How can you make this happen? Benchmarking, retrofitting, implementation. These are the 3 key parameters that can be explored if we are to make a building more energy efficient. But the question again remains how. So if I talk of how, so once it is mandatory, it has to be followed by everyone in the country. So the best possible outcome can be a policy intervention. So policy reforms and enforcement is one thing that we at India are looking at. Because policy is something, if in case it is developed by, it is implemented and enforced by government, so it has to be followed by the Indian developers. They are not left with any choice. They will have to follow the Indian codes and policies. So this is something we are looking at. Policy level interventions in India. So India, being the second largest country in terms of population, we have somewhere around 1.324 billion as per 2016 census report, which is a huge number. Seventh largest in terms of area, 3.7 million square kilometer, which comprises of 29 states. And we have the longest constitution in the world, 465 articles, 25 parts. You might be thinking why I have highlighted having the longest constitution. There's a reason behind that. India is very strong in terms of policy and mentioning about the policies. So India have a good high policy intervention systems available. So it is not a requirement for India, it is the necessity for India to channelize all the states available under the guidance of the longest constitution. So it is a necessity for India to have such robust system in place that if a policy is overlapped, so what can be the next step taken against the person who has overlapped the policy. India, being the signatory in the Paris Agreement, is committed to keep the global warming temperatures well below 2.2 degrees Celsius. So I'm not saying that India will achieve that, but India is committed towards achieving that goal. We might even end up having a target of 1.5 degrees C. Basically, as a result of which, India launched a National Action Plan for Climate Change, NAPCC, which encompasses of 8 national missions, which are listed here. So I'll be taking up the top 3 missions, although I would be going through all the 8 missions. So National Action Plan for Climate Change comprises of 8 national missions. National Solar Mission. So National Solar Mission, basically, if many of you might be aware that International Solar Alliance has been formulated in India. It is basically a country-based treaty. So 121 countries have already signed the treaty, and and it is in final stages of setting up its headquarters in Delhi NCR region. The headquarters, it is being headed by Ministry of New and Renewable Energies in India, and under the guidance of Ministry of New and Renewable Energy in India, and with United Nations Environment Program. It is being led by Mr. Tripathi, A.K. Tripathi, who is the director for the National Solar Alliance mission in India. He is basically an IAS officer and has served for the Ministry of New and Renewable Energy for past 30 years. The main aim of this mission is to generate a potential in the countries and to help other countries achieve those solar targets. So India has committed, our target is somewhere around achieving 100 gigawatts by year 2022. And we already have a 3 gigawatt of installed solar energy power that is existing in India and is powering well across the India. And it is powering the grid, and grid is in the end powering our houses. So 3 gigawatts is what we have right now. 100 gigawatts is somewhere what we are looking till 2022, and 500 gigawatts is the current solar potential of India. National Mission for Enhanced Energy Efficiency, NMEEE as we say it. So it is basically targeting the Enhanced Energy Efficiency program in India. I'll be taking up it in the further slides. National Mission on Sustainable Habitat. So National Mission on Sustainable Habitat is one thing that is aligning well with the National Housing Mission for All. So this basically covers up the social housing scheme that is being run in India. It targets to build a house for everyone, not just the rich people, but for everyone. Exactly, I'm saying everyone because it targets creating houses at a cost of around 8 lakh rupees. And while I'm talking of 8 lakh rupees, you can just calculate it, it would come around somewhere $20,000 Owning a house in India in $20,000 is still a dream, but this is something that they are targeting to achieve. They have already achieved in some certain states, but it is not essentially possible getting through the states of Delhi NCR at this rate, because coming to the economic impact, people won't allow that much of a rate to be going down in the Delhi NCR region. It is one of the prime locations. In Mumbai, there is no social housing projects as of yet launched, which is completely built. They are in phases to be built, but have not been yet built. So this is one mission that aligns with the National Housing for All. National Mission for Green India. So basically, this is about the afforestation. So India has cut down its trees dramatically, and then this mission targets about the afforestation in India. So National Mission for Sustaining Himalayan Ecosystem. So Himalayan ecosystem has been disturbed because of the global warming. The glaciers are melting these days. So we had, everyone in the world knows about the earthquake that hit India in the Uttarakhand region in the year 2013. And it was a major devastation then. So it was basically it happened due to the ecological imbalance that was created at the glacier level in Himalayas. So this is what we are targeting of sustaining the Himalayan ecosystem. National Water Mission, so basically making water available in each and every state to be able, and making drinking water available. We have water in major states available, but it is not fit for drinking. So National Water Mission targets to that. National Mission for Sustainable Agriculture is basically targeting the development of sustainable agriculture, and it relates to something called as high-yielding variety for seeds. National Mission for Strategic Knowledge for Climate Change. So this is something important that I would target upon. So National Mission for Strategic Knowledge for Climate Change. This is basically the knowledge dissemination that is required. In India, we have a limited pool of trainers available, and then a knowledge sharing platform is something that that is to be built in India. So a climate change library, a climate change group, a climate change experts, a pool of experts is required to target this. And we at this gathering, there can be no better stage to ask you all to provide inputs on climate change for the Indian context. So policy level programs, interventions in India. So Bureau of Energy Efficiency, as I was saying, that I would cover the National Mission in Enhanced Energy Efficiency, because the other missions were not aligned with the context of today's presentation, so I'll briefly describe upon them. But I'm taking this National Mission for Enhanced Energy Efficiency, NMEEE, in detail in the further slides. The Bureau of Energy Efficiency, which is the nodal agency for any energy efficiency activity that takes place in India. So Bureau of Energy Efficiency, it is a nodal, it is under the Ministry of Power and acts and has set various targets under NMEEE program, including energy efficiency in the building sector and industry. Some of the highlighted programs are as follows. Energy Conservation Building Code. So India has its own Energy Conservation Building Code, so which keeps on revising on every twice a year. So basically on a bicycle. So we have, since it was revised somewhere in 2017, so the next revision would come in 2019. B star rating for existing buildings. So B star rating is basically a benchmarking program, and it helps incentivize the buildings based on their energy performance. Standard in labeling. So this is a general program that is quite famous across the world, in which the appliances are rated as a star rated appliances or the Energy Star, or there can be other parameters as well. Performance achievement trade scheme. So this is something unique that Indian market and Indian government has developed. I'll take it upon in the further slides. Market transformation for energy efficiency. So this is something that these two policies have been developed and derived from Indian market and now taken up all across the world. So Energy Conservation Building Code, as I was talking about. So it's a regulatory framework which comprises of guidelines for building energy efficient buildings and the process, and mandates minimum building energy performance. So any commercial building being built in India having a connected load of more than 100 kilowatt has to be ECBC compliant. ECBC is basically Energy Conservation Building Code. Sorry, I missed that. Okay, I have mentioned that in the presentation as well.
You have about 3 minutes left.
Sure, I'll wrap it up. So it consists of three typologies: ECBC, ECBC plus, and Super ECBC, based on the energy performance of the building. So buildings are rated in those terminologies. So enforcement, basically. So this is where the investment comes from. Since it is mandatory for the buildings, so that's how the builders are now trying to invest in certain lines. So having a more than a connected load of 100 kilowatts, the builders are now mandated to invest on the energy efficiency aspects of the building, whether it is an existing building or a new building being constructed. B star rating for the existing building. So this is a simple energy benchmarking tool available. So in this tool, energy EPI ratio, basically energy performance index of a building is calculated, taking around 3 years of their build data. Energy performance is calculated. So energy performance is basically kilowatt hour per square meter per year, and then the building is rated. So energy incentives are provided based on the performance of the building in form of tax reforms that is to be paid by the builder. Standard in labeling. So basically this is the energy star rating program. So it mandates 10 appliances. So manufacturers have to so for those 10 appliances, if we talk of air conditioners, refrigerators, so manufacturers have to align themselves as per the schedules given by BE, and then those schedules are pretty strict and stringent. Quality checks and balances are maintained at a level that is, there are random checks that are being done. So BE star rating programs mandates the use of 10 appliances as the energy efficient appliances, and then they have to come with a label affixed on them. So it was launched in 2006 by year 2010 if we say it. So it resulted in a savings of 336 avoided capacity generation. So the electricity was not generated for 336 megawatts of hours. So that is a lot of, as if I compare to Indian market. Performance achievement rate. So this is something unique and has been first time implemented in India. So the designated consumers are selected basically based upon the energy performance and energy demand, in which the consumers are given a target to reduce their energy consumptions. This helps the consumer basically to invest. How? I'll come to that. They basically invest in energy efficient system, and then it is a win-win situation for them. They reduce on their electricity loads, and then again the reduction is given as an incentive. So electricity certificates are given, ES certificates as we say them. So energy saving certificates, which can be then traded to other consumers who are there and were not able to maintain or meet their goal. So these certificates can also be traded. So this is one of a kind policy intervention that has been taken up by the Indian government. Indian government is again ready to invest. They have a partial risk guarantee funds available to be invested in this scheme. It is known as the PAT scheme, Performance, Achieve and Trade. So as the name suggests, so building performs, it achieves their goal, and then they can trade their the savings that they have achieved. So, and this can be one of the policy intervention that can be taken across the world. So this is some unique policy that has been developed by Bureau of Energy Efficiency. Outcome of this, the PAT cycle 1. So it has resulted in somewhere around 5635 megawatts of energy savings has been done, which is 1.25% of the total primary energy saving. The emission reduction due to this. So 31 million tons of CO2 emission has been reduced, has been basically saved.
2 minutes most. Sure. Time's up.
Sure. I have been given a warning again, so I'll just wrap it up. So capacity building has been one key aspect. So savings of 9,500 crores has been done through this, and investment in the energy efficient technologies is 24,517 crores, which is almost equivalent to 1% of the Indian budget. If I'm talking of an Indian budget, so 24,000 is a pretty big amount if I'm talking of. Market transformation for energy efficiency. So basically, a public sector undertaking has been set up by the government under the Ministry of Power. It is known as Energy Efficiency Services Limited. It is the government agency which works upon bringing about energy efficiency for the end user. not for the builder, not for any developer, but for the end user. So what they target is the basic use appliances like refrigerator, LED bulbs, and now they are venturing into the chiller market as well. So they basically work on the demand aggregation. Once they aggregate the demand for any product, so they basically do the bulk procurement and reduce the cost of the equipment. And then the features of this basic policy has been listed as the bulk procurement, cost reduction, and massive energy savings are one key aspect. The Ujala scheme is one of the examples of this bulk procurement. So it was launched by EESL. And has resulted, so if I talk of a LED cost, so 2 years back it was costing somewhere around 400 rupees, and now it costs almost 1/4 of what it was costing in 2 years back, and this is all being done because of this scheme being in place. The features of this scheme is such great that now we are helping the Thailand government of Europe to have the energy efficiency. Energy efficient street lighting in place. So they come with a live tracking system. I'll just show you. So this is the Ujala dashboard. So this was taken on 14th April, like yesterday, somewhere in the evening. So it has resulted in a savings of 38,420 million kilowatt hours for a year I'm talking of. So this is quite big. Investment saving of 15,000 crores. Reduced, so avoided annual peak is 7.6 kilo megawatt, basically 76,092 megawatts, and CO2 emission is 3 lakh tons of CO2 equivalent has been reduced. So conclusion, basically reduction in GHG and CO2 emissions is inversely proportional. As we increase the energy efficiency in the building, the CO2 emissions go down. So this is something that we need to target upon. To make the buildings more energy efficient, policy interventions are required along the side, along with the design and technological options, and with the funding schemes and economic feasibilities of both. Training and capacity building of professionals to upgrade their knowledge with the latest technologies, energy benchmarking tools, energy performance indicators. So challenges, if I talk of, generation of a pool of trained resources is required. So India lacks somewhere in developing those trained pool of resources is not available in India. So this is one of the challenges. Then second challenge comes as a knowledge for the climate change and possible mitigation options are required. So these two challenges are not being tackled by the Indian government. So we have a limited pool of people available who has the knowledge on climate change, and a pool of trained people who can enlighten the industry more towards the energy efficiency is still remaining. So with this, I would end the presentation. So with the quote, technological interventions can bring about reform, but policy intervention can entirely transform the market. Thank you.
Thank you.
To contact, you have the contact details.
We will keep the questions to the end because this is a forum, a panel. So instead of questions, of course there will be questions, but I would prefer to have a bilateral or multilateral discussion, because we are going to try to draw a roadmap, and I will note them down. It's my duty. So I would like to thank you for the good job, and Akil has mentioned especially the policy level and the activity levels for efficiency in buildings, in the built environment in general, in order to reduce the carbon footprint. As I said, as I promised, this is a very simple example. Exchange rationale of air-to-air heat recovery in HVAC systems with special emphasis on compound CO2 emissions responsibility. In the quest of what's next in reducing carbon footprint, because as I will be mentioning in a few minutes, the first law of thermodynamics has already accomplished its mission successfully. Little room left. The remaining is subject to law of diminishing returns. Consider a condensing boiler, efficiency higher than 90%, 95%. So what's the room left? You have to maybe spend billions or millions of dollars to increase it up to 98%, but it's limited to 100%. So we have only a little room left for reducing the carbon dioxide emissions. What's the relationship between the sustainability and carbon dioxide emissions in a compound form, which means directly that you are responsible from your chimney or indirectly from the power plant and etc. We have about 6 elements. In 3 days we have, and distinguished authors and lecturers have already covered these. We have to use clean fuel or alternative fuels. Number 1. Efficiency, as I already mentioned, from the first law point of view, efficiency is not too bad. New technologies, improvements, but efficiency is coming to a saturation point. We cannot do too much. Well, of course, the number 4, the thermal loads, of course, we will continue to conserve energy, heat, or conserve the power load, reduce the loads. But if you can see, except efficiency, the thermal load and the power load reduction or the energy conservation is directly affecting the carbon dioxide. If you reduce them, yes, carbon dioxide will be lowered, but in a directly proportional manner. 10% directly reflects 10%. And of course, power plant and grid efficiency are also concerned. Smart grids, etc., are on the way. So, number 1, the fuel. Number 2, efficiency. Thermal loads, reduction. So, energy efficiency, load reductions, power plant efficiencies and grid efficiency in the same token, and the power. So, what's this box number 3? What's this? That's what's next. What's next is a term called 2 minus psi r, and psi r is the exergy rationality, exergy efficiency, or the rational use of energy in a better balance between the demand and the supply qualities of energy. Like if you use natural gas just in a boiler to heat your building, its exergy efficiency is only 6%, while its first law efficiency is 95%. So there's a big difference. So here, as I said, you can improve by 5%, at most 10%, but here you can have up to 80% or 80 points improvement. And this is just a matter of logic. It doesn't need rocket science. So in this case, this is a strong indication that what's next, the answer is here. What's next is the rationality. And this directly reflects to our dilemma about the sustainable development and carbon dioxide emissions, which is the topic here. Just to sum up, this is except efficiency, psi r is the only parameter here that affects indirectly with the carbon dioxide emissions, which shows you the early signs of decoupling, which is the problem here. So as the efficiency, exergy rationality increases, carbon dioxide decreases, efficiency may increase a bit. We have limited possibility there. Same thing for the power plants with cogeneration and other high efficiency power plants, etc. They will affect, but the power load, the thermal loads will also affect. And the result is carbon dioxide is reduced. But let's see how it is affecting the sustainable development of the current. This is a slide that I have already shown at the opening speech. Unfortunately, whatever you do, the current trend is carbon dioxide emissions by time is following you, chasing you. It's a nightmare. Sustainable development is coupled with the carbon dioxide emissions. Yes, we can reduce it a little bit, like by savings, but as I said, they are linearly proportional, so you can only shift the line below, but it's still parallel. Or increase the efficiency. It is inversely proportional, yes, but we have limited possibility remaining there, so you can tilt the line, but still you are on the positive side. You are still coupled with. So what's next? Rationality. Because I already shown in this equation that higher the rationality, inversely proportional, you get carbon dioxide in a much more effective way reduced. So that's next. And in order to explain you very shortly what this exergy means in a very simple example, air-to-air heat exchanger. And that, again, let's remember that carbon dioxide is proportional to the inversely proportional psi r. So, I have already mentioned that. So, it's the turn of the second law. That's a reproduction of the diagram from the ASHRAE handbook, which thermodynamically analyzes an air-to-air heat exchanger in its simplest form. It says outdoor air coming in, heat is recovered from the indoor air in winter mode, higher temperature, and is exhausted. And there's a heat recovery interface, whether permeable, impermeable, or negligibly impermeable. But that's it. And of course, this is enough for any thermodynamic student or heat transfer student to do the calculations, heat exchanger efficiency, etc., for a given design conditions. But what about, to start with, how do you suck in the outdoor air? By a fan, an electric motor, and also most probably the indoor air is exhausted by another fan. So these fans are operating on power. So they demand some high exergy power, which is electricity. The electricity has a unit exergy of 1 almost, or 95 practically. And what in turn you are gaining is from an outdoor air TO based on the simple Carnot cycle to the inlet air, let's say TR, times the amount of heat. That's the quality of it, and that's the total quality of it. So you just obtain a rise in exergy in terms of TO and TR. But let's look, in order to achieve this exergy jump, how much electricity in terms of quality you are spending. There's the table taken from a company catalog. It gives the airflow rate, the thermal efficiency, 65%, 51%, and it gives some typical numbers for the temperatures, boundary temperatures. But look at this. This is what heat in kilowatts is a capacity for number 1, 2, 3 models. You get about 8 kilowatts. That's what the company catalog ends. That's it. And maybe at most, it only just gives how much electric power you are spending. There are 2 fans, about 0.45 kilowatts or 55, etc. And how nice. They claim that the first law of COP, when you divide the red into the blue, 8, 7.45, 8.4. Fantastic. You pay 1 electricity, you get 8 heat. But what about the quality? What you pay, what you get, one is maybe a dime, is silver, the other one is gold. So there is a definite difference. And according to the second law, look at the COPs. 0.23, 0.157, 0.16. So from the quality of energy that you are using doesn't pay back. You get much less quality-wise energy. And don't forget, this is the rationality, and lower the rationality, higher the carbon dioxide emissions. So that's what we call the compound carbon dioxide emissions. It's not going through your chimney, but you are responsible for that because you destroy the quality of the energy that you are using, destroying the electric power just for a fan, just to get a little exergy increase in your air. It makes sense, but exegetically, what this shows you as an engineer, Again, I have to distinguish between an engineer and engineering. Engineering is something that appeals to everyone, architects, scientists, doctors, lawyers. To engineer means to find out the solution. And it is engineerable. You can find the solution. How? Very clean. You just try new designs to reduce your fan requirement. Maybe with 3D heat exchangers, the 3D printing, with the optimum heat exchanger media, more efficient fans or fanless, natural convection type of heat exchangers, whatever. But it shows you the problem, but at the same time shows you the solution. But which law shows that? The second law. Because otherwise you are happy. COP, what's the COP? 8. How nice. And economic, it might be also economical. Let's move. But instead we developed the exergy-based model, which now you expand this box, put the fan in, put the fan motor, but just go back to your fuel input. And you will see how much carbon dioxide you are responsible just for elevating your temperature from 10 degrees Celsius to 17 degrees Celsius. So we distinguish the powertrain, we distinguish the heat recovery process, and it also includes on the downstream the terminal units. Where do you use this warmed up air? So this triple combination gives you the exact solution. And first shows the problem, but it also brings along with the solution. And in this respect, of course, you have to go way back. In this case, the Turkish power generation mix, because this is going to give you either fossil or renewable, how much average efficiency you have, total share, and the carbon dioxide emissions. So you have to go way back to your power mix, just for a simple heat exchanger. And for that example, as you see, as a repetition for winter, your COP must be actually 41, which is impossible, to make it even, exergy-wise. In summer, it's a little bit better, 31 about. But again, as you see, you have to do something. And the findings and the proposals are here. In other words, sustainable solutions and equipment need to be rated by the second law. I am not trying to negate the first law, but it should be appended by the second law. Carbon footprint must be calculated accordingly, etc. They are all written here, and we'll be discussing that. I'll keep this on the screen later. The solution domain is endless, like a PVT. In wintertime, of course, you can have your outdoor air by probably with a larger ducting system, with a good design. Natural convection may heat your air in crowd-free while you are cooling the PV, but there is a dilemma here, actually what are you going to do in summer? So every solution brings its own problem. That's the engineering. Well, heat pump. Again, for heat pump, getting as an output 55 degrees Celsius heat at 1 kilowatt of electricity, your COP minimum must be again 7.2 to become even. And as you see, the exergy-based COP is less than 1, although your COP is enjoying numbers like 5. Your exergy-based COP, which is actually comparing what you get in quality terms and what you put in quality terms, is less than 1. You're in the loss. So why do I use it? And this less than 1 part is your destruction. And it has an implication on your carbon dioxide emissions, because you are wasting your electric power. And in equal amount of the wasted electric power, you are going to demand that amount from the thermal power plant again, at an expense of additional carbon dioxide. This another way, production well, reinjection well for geothermal, you can find such solutions, organic Rankine cycle, getting power, and the waste heat might be used to preheat your air, etc. And embodiments, we never covered, unfortunately, in this symposium, or maybe missed. For high-rise buildings and for the air-to-air heat exchangers, these are typical materials like aluminum, glass, refined copper, polypropylene, steel, and aluminum is the highest. It's the lightest, but it has the energy embodiment and associated carbon dioxide embodiment in exergy terms. It's the worst material. And especially for high-rise buildings, these glass facades with aluminum frames, I don't need to say anything more. They are, I am sorry to say, but terrible. So, as a result, you have to devise or draw such diagrams, in this red case, for any equipment, in this case the air-to-air heat exchanger, you have a material data, and according to it you just calculate your embodied carbon dioxide, if and only if your electric power consumption in quality-wise is less, which means you are really contributing by heat to the system, then you may have a positive and real solution. If you are spending as much electric quality as the heat you receive, nothing changes. Or if it is less, you can never get any payback. So these diagrams will help you to find out, or the roadmaps, and the roadmap is this one, this line. The rest, don't bother about them. So, that's another different view, but I think I was able to give you what is the next step, quality. And thank you very much. Now I open the floor to questions and to comments. We have some time, about 15 minutes. Yes, please.
Thank you very much.
Have more time. Yes.
I have a slightly technical question on the 2 minus psi r.
Mm-hmm.
I know you've written papers on these, and could you give us a very quick explanation for the 2 minus psi r without having to go into a lot of details? But
Involves 2 minus psi r involves the destroyed exergy. The 2 comes from 1 plus 1. The first one is the carbon dioxide emissions that you are responsible from direct combustion or whatever from your boiler, times the Q or the heat amount. The second one is 1 minus psi r is directly related to the destroyed exergy part. And that destroyed exergy must be replaced or accounted for by another system, a thermal plant, another boiler, whatever, a solar system. So this 1 minus psi r by itself is the irrationality, which means that you are not balancing your heat demand or energy demand with the supply. Like as I said, psi r is only 0.06 in a condensing boiler if you use it for just space heating. So higher the psi r, that 1 minus psi r, if approaches to 1 minus psi r approaches to 0, so psi r is a measure of your rationality, how balanced your demand and the supply quality of energy. In this case, for example, aren't we going to use natural gas? Of course, but first maybe a cogeneration system, and then some other applications which adds value to the society and to the economy, and then the waste of the waste heat maybe finally in a radiant floor heating at maybe as low as 35 degrees Celsius may be used. So you have to fill out this blank in your exergy diagram with applications, useful applications. That's the idea. So what should we do as a roadmap? We have spoken about the policy making, which is important, education, maybe the quality-wise. My dear Professor Yalçın Gürüş is here. I am sure you have ideas. He told me exergy. He is responsible for that. Thank you. No questions? Okay. Any other ideas on what should we do? As I said, we need in technical terms, don't misunderstand it, not political, but a revolution in science and technology in building science, built environment, energy.
I wanted to combine both presentations because we had some very good best practices from India on the national missions for solar energy, for water, and for different areas. And on the other hand, the challenge of reducing CO2 emissions. This is also a challenge, but now we don't have a mission, a national mission or any kind of mission. What would be your cross-exchanged views on maybe launching a pilot site that shows how energy resources could be used more rationally? So could be like a pilot district, and then maybe if that pilot district is successful, could we also design our own national framework for a sustainable built environment using exergy principles?
Well, thank you for the question. As the main title of this symposium is Climate Responsive Design, first of all, every country should develop its own policy and its own measures. However, this doesn't mean that there should be no cooperation. We should have the strongest cooperation, not on a building scale, but district scale, city scale, town scale, even country scale. But every nation or every country should modify accordingly to their own climatic or other conditions, even cultural conditions. But definitely we should elaborate together, and we should phase out and phrase out all the main common topics. There are common topics, and we should then elaborate on these common topics. Once we get a consensus, a good roadmap, then we can elaborate on them again, still continuing with the best and the most possible way of cooperation. International cooperation is important. Exchange of information is important, and I hope this forum and this symposium will be a benchmark and a milestone of collaboration. I am looking for that. We have to concentrate and focus on our future today with a scientific revolution. We have to break our barriers, break our boxes, and we have to think out of the box. As I said, we have to change the game. We cannot play the same game. The game should be changed forever. Thank you very much. Do you have anything to say? Other comments? And I am sure you have something to say now? To close? Okay, the question was, do we need a governmental or, government policy? Of course. Intergovernmental policies, IPCC, there are already, she might give more information. There are intergovernmental policy-making agencies. This is a must. Governments should write down the rules, but the problem is they just write the rules. They don't follow up. The rules are just kept on dusty tables, mostly. So that's not the solution. They should be directly involved, actively involved, and they should follow up what they write down. If they don't follow up, it's maybe just an academic study or a law, which usually happens in Turkey. The laws are not applied or guidelines. We should be very serious. And in this respect, of course, the governments should also be in touch with each other, get information from each other, and cooperate. Yes, please.
Would an ASHRAE standard or an ANSI standard or anything that would be a step towards enforcing or forcing the designers to take that into account. Would that be a good way to start, or is that
Yes,
too,
actually it's a bright idea, and maybe we should do it together, but in ASHRAE or other standards organizations, TSE in Turkey, we should have but workable and long-living standards, realistic standards that every partner in that sector should obey, willingly obey, and use it. This is a good step, and unfortunately we don't have any work on this topic, but in Turkish Standards Institute we had a new not green building actually, it is safe and green building, including the nuclear or VOCs, everything, because even a marble has some radiation effect. Including these, we just put a couple of simple exergy points in addition to the existing other green building codes, like where are you using your natural gas? What's the percentage of using your natural gas in heating? What kind of heating? Do you recycle the heat, etc.? In what exergy terms? So this was a good start, but again, it's not working. It's a Turkish standard. You can find it, but who's using that? That's the problem. And yes, please.
Hello. My name is Hakan Aykaç, mechanical engineer. 27 years I've worked in climate systems. But you said, everybody said, and try to manage how control the systems, maybe carbon dioxide, but nobody asked. For example, this area, I think 6 or 7, 70 person in the rooms, the salon. Now, and the electrical, air conditioning system work, and a lot of energy. In 3 days, we consumed. So, if we divide 70%, the person ratio very big. I think we ask myself, ourselves, we managed this problem. So everybody, I think, understand what I explain. Please, now maybe we think this problem. Thank you.
Control should be also quality based. Any last minute comments?
I would like to emphasize the sustainability concept with regard to development of the human civilization. In the very long past, it was a problem to achieve anything at all. Later on, in 18th century, we have emphasized the importance of efficiency. Now, recently we begin to think in terms of sustainability. The three essential components of sustainability are known as social, economic, and technological sustainabilities. However, we may not be very strict on these partitions, and let us consider sustainability as a whole, because it can change, and by our time, the development of sustainability is the essential of all human development. I think, is it acceptable
Of
or
course.
too exaggerated?
No, it's
Thank you.
very acceptable. Thank you. Any comments, questions? I think the time is up, but we might have a few more minutes because we should take the chance or the opportunity to be here, because I think we have to still write a roadmap. While you may be going back home on your plane, just jot down a few points and please send it to me. And we should discuss it all over the societies and members and the attendees here. If there's no any other comment, I would like to take the liberty of ending this forum session and thank you, each of you individually, for your attendance, for your patience and your contributions. This was great, and I have learned from questions a bit more. This is a learning curve, this is a learning process. Learning has no ending and engineering has no ending. Thank you very much.